So today we're going to talk about arc length, and it's some pretty cool new stuff for us today. But even before we start with the new, let's go back to the old. So let's talk about a line. So I'm going to draw a line here. Whoa, I did not mean for that to be green, but that's pretty cool. I love it. All right, so that line that I have there, if I were to measure that line, I can measure it in a number of different ways, or a number of different units I can use to describe the length of that line. So I can measure it in terms of inches, I can measure in terms of feet, I can measure in terms of centimeters and millimeters. So there are many different ways I can measure a line. Well, we've been talking about circles and we've been talking about angles. Well, there are a couple or a number of different ways. Well, there's a different way that we can talk about the angle of a circle, or the measurement of the angle of a circle. And that's going to be radians. Now, just so you know, you are going to be dealing with radians for a very long time in your math lives, and that's a good thing. So let's talk about the radian. The radian is the measure of essential angle, and we know what essential angle is. That's the angle that's formed at the center, okay, of the circle. We call it theta, okay, and it's equal to the ratio, relationship, fraction, all the same, of the arc that the angle intercepts, okay, the arc that the angle intercepts, or sometimes it's called subtends. You may see that, and we use an S for that, divided by the radius, and we all know what the radius is. So if I look at my picture here, my S, all right, the angle that's intercepted, okay, that's going to be S. We know that the radius is my R, and then the radian that says that it's 1 radian degree measure, all right, that's going to be my theta. Okay, now, so we have our formula here, and it says our equation, theta, all right, the radian measure equals the arc length divided by the radius. We're going to change that around to help us, because we're going to be looking for different parts of this equation. And a really big help is if I were to do a little algebra and multiply r to both sides of that equation. Well, here it's going to cancel, and I'm going to get the arc length, that's this S piece, equals O, or theta, I should say. Oh, I can't believe I just said that, times the radius. That is theta, the radian measure. Now, something very important, our radian measure obviously is going to be in radians and not degrees. So when we're using this formula, and we're going to see more of this later, we need to be in radian degree measurement. And just as a side note down here, it says that an angle of 1 radian intercepts an arc equal in length to the radius of the circle. And that just makes sense. And we'll see that again a little later on. So just some important pieces here. I'm going to write down that S equals my arc length. Theta is my essential angle. In radians, very important. And then R is my radius. I'll put that here. Okay, R is the radius. Now, I've heard this before, and you can use it. Just a good way to remember, and you can call this SOAR. All right, that's just a good way of remembering that the arc length equals theta, central angle times the radius. So if those conditions appear in a statement or a question or a problem, you're going to use SOAR. And it is not given to us, so we're going to have to remember it. So let's take a look at some problems. So example 1 says, in a circle whose radius is 20 centimeters, let's get the highlighter out. The radius is 20 centimeters, and a central angle intercepts an arc, or subtends, of 15 centimeters. Find the number of radians in the central angle. So what I'm going to do, and I think you should do, I'm going to write down what's given. So I have the radius equals 20 centimeters. I have S, okay, or my arc length is 15 centimeters. And I'm looking for the central angle. All right, so I'm looking for theta. So I'm going to write down my equation. S equals theta times the radius. All right, now I'm going to fill in. I have 15 centimeters. That equals theta times the radius of 20 centimeters. I'm all into centimeters, so that's good. So I'm going to divide both sides by 20. And my answer is going to be 3/4. So theta equals 3/4 radians. Okay, let's take a look at number 2. So number 2 says that a central angle of pi over 4 radians intercepts an arc of 3 inches. So let's highlight. Again, I like that. I think highlighting is important. So central angle is pi over 4 radians, and the arc is 3 inches. We're finding the radius, and we know we're going to use SOHR. Theta times the radius. I'm going to write down what's given. I have my central angle, or theta, equals pi/4. And then I have that my arc length is 3 inches. I'm going to substitute in. I'm going to get 3 equals pi over 4 times the radius. Okay, now what I like to do, since I have pi over 4 divided by r, I want to get r by itself, and I have a fraction. I just think it's easy to multiply by the reciprocal. So I'm going to do that. So I'm going to have 4 over pi on this side of the equation. Then I'm going to multiply 4 over pi on the other side. Okay, I'm going to cross cancel. That equals r. And then I'm just going to multiply across, and I'm going to get 12 pi. And that's your answer. So I would just write r equals 12 pi inches. Okay, let's go to example number 3. It says in a circle of radius 9 centimeters and a central angle of 5 radians intercepts an arc of a circle. Find the length of the arc. All right, so once again, I have theta equals 5, that's central angle. And then I have a radius equals 9 centimeters. I have my equation, the arc, and that's what I'm looking for. I'm looking for the length of the arc times the radius. So S equals 5 times 9 centimeters, and S equals 45 centimeters. All right, last one. An arc of a circle that is 6 centimeters in length. So the arc is 6 centimeters. Intercepts or subtends a central angle of 1.5 radians. Find the number of centimeters in the radius of the circle. All right, so I'm going to, once again, I really think it's a great strategy to write down what you have and then substitute in. We know we're going to use our equation. So in this one, I have my arc, or S, equals 6 centimeters. And what else do I have? I have my central angle, theta, that equals 1.5 radians. All right, so here I go. So now I have 6 equals, well, 1.5. So I'm looking for the radius, r, so I'm going to divide both sides by 1.5. I'm trying to get r by itself. I'm looking for the radius. Okay, that cancels. And I know if I use my calculator, which I can, and I should, r equals 4 centimeters. Okay, so once we get used to our new language, our new equation, okay, new definitions, radians, that new unit of measure for angles. I'm telling you, you're gonna use that a lot. Once you get used to that, you know, it becomes pretty straightforward for now. Okay, so what I want you to do, obviously, is write down some key ideas, check your understanding, write down some questions that you might have, and we'll go over those examples tomorrow. Go Cats, go Knights.